Professor Dr. John Isaac, Dean of School of Computing, Engineering and Technology at Robert Gordon University, United Kingdom. Dr. Isaac is a renowned researcher with expertise in visualization, simulation, and digital innovations, shaping solutions across engineering and computing domain. Today, he will be delivering a talk on building smarter cities, the power of interactive digital twins for strategic decision making. Please join me in warmly welcoming Professor Dr. John Isaac to the podium for his keynote address.
Thank you for that lovely introduction. This is my second time at Bahria University. My first time was here in March, and I gave a presentation about pirates. So I'm very happy that I was still allowed back. What I'm going to talk about today is a particular research that we're doing within the university that I'm from in Aberdeen, but also that includes some game technology that will be interesting to some of the younger members of the audience. Not that I have anything against the professors. So first of all, I'm going to start with a question. How many of you have had to make a decision but not had all the available data? Well, stick your hands up if you've ever had to make a decision but not had all the available data. So the rest of you can all make your decisions fine, okay? All right, let's see. But quite a few of you did put your hands up there. This is the problem that we have. We have an issue where when we try and make any decision about a big planning project, a big infrastructure project, or a big system, we don't have all the data that we need in the format that everybody who needs to make that decision can access or have access to. That data might be in graphs, it might be in Excel sheets, it might be in PDFs, it might be in a whole range of different data formats that won't be understandable to everybody that we need to involve in that decision. Decisions are complex. The type of decisions that we're talking about are complex to make. Traditionally, these decisions were made by experts, people who worked with that data all the time, people who study the data and know what that decision is going to be made about. More recently, we've moved into kind of collaborative decision making and public consultation, where that decision maker might then meet with some people who are involved in that decision, the stakeholders. More likely, the experts will be meeting with the actual decision makers, the people in our councils and governments and local governments who actually have to make those decisions on the ground. But more increasingly, we need to include everybody in these decisions. We need to include the people that it affects. Community decision making. If we're going to make a decision, perhaps on some kind of flooding prevention, or a new energy system, or a new type of development, or a new road, we want to engage people in those decisions so that they support the decisions that we're making. To do that, they need to understand the data the decisions are being made about. The impact of making a wrong decision is huge. Financial. So in the UK, traffic gridlock costs us about 307 billion. Okay, so significant amount of budget lost from traffic gridlock. People not getting to work on time, dealing with the pollution that comes from that. All of these problems about incorrect decisions or not being made, or a decision not being made because the data is not there to make the decision. Health and well-being. Unplanned urbanisation reduces green space by as much as 75%. If we think about the lovely green areas in Islamabad, would you want to have decisions made that removed 75% of those green spaces? No, because it's a beautiful city. Why would you do that? And it's the same in cities right across the world. But how do we involve developers, communities, people that live in these spaces in those decisions when they're made? And then finally, the environmental impacts. The impact on our local environment and the environment of the people that live there as well. So air pollution, kills more people than actual traffic collisions. That's an amazing stat. It's a terrible and horrific stat. The air pollution from traffic kills more people than the actual traffic accidents themselves. Heat islands recently in Europe, so this is where heat is centered around an urban center, has essentially raised mortality rates by 4.3% across Europe. So big issues with wrong decisions being made about planning. So what we've done in Scotland, we have developed something called the Digital Innovation Lab. Digital Innovation Lab was a project that was funded by the Scottish Government. It was funded from a fund called the Just Transition Fund. And this fund is about encouraging decisions to support a transition from oil and gas to renewable energy sources, or a transition through reducing energy use. To reduce energy use, you need to understand what your energy use is in the first place. What the lab lets us do is recreate any real environment in a virtual space. And what we've done with it is to create a large-scale digital twin of an entire city, and soon that should be a digital twin of the entire northeast of Scotland. You'll all have heard of the term digital twin. Usually this is a system, a miniaturized version of a system, or a digital version of a system that you can use to display information about a real system. We've done that for an entire city. Taking in all of these types of data, objects, processes that happen in the real world, and displaying them in the digital twin of the city, and being able to use that to make decisions about the city and its future development. So many of you have been to Aberdeen. Yeah, you have. Anybody else been to Scotland? A few of you, great. Aberdeen is in the very northeast of Scotland. I wanted to highlight where it is compared to Pakistan. Aberdeen's a beautiful city. It has beautiful architecture, which obviously we don't want to damage when we're trying to reduce energy use. It has a beach, it has lovely granite buildings. The buildings are quite old. So how do we make those buildings more efficient? Where do we put our finances to make those buildings more efficient? What's the most efficient way of creating a greener, just transition? Also, in Aberdeen, we're trying to move from oil and gas to wind. So there's a big energy change in the northeast of Scotland, and actually the UK. Aberdeen is the centre, oil and gas centre of the UK, and it's where most of the oil comes onshore. And this is the process that we've taken. So all of that information that's used to create and about a city, all of that real information, we take LiDAR point cloud scans. I'll talk through some of that in a second. But we use data analytics. We take information from GIS systems. We take information from databases that are held by the councils, the stakeholders, the government. We then create representative models. This might be models of new spaces, new designs, new buildings. And we put that into our platform, and we create what we're calling a high-fidelity digital twin. This is one of our scanners. So, anybody used a LiDAR scanner? One person. Excellent, right? LiDAR scanner, this is what we call a terrestrial scanner. If I asked you to create a model of this room by hand, you would probably walk around with a measuring tape, and you'd measure the four corners of the room. You might measure some other spaces along the way, just to get certain objects, the air conditioning units, the beams, the lights, the slight dip in the roof. Would probably take you about half an hour to collect probably about 20 points that you'd need to build a model of this room. This scanner does 2.4 million a second. So that's the type of accuracy we're getting. We can scan a large area really quickly and down to millimeter accuracy. So not only are we creating a representation of a real environment, it's a highly accurate representation of that environment. So we know we can recreate the physical space. Whoops, too far. Go So the type of data that we're using, we bring in aerial LiDAR. So we flew a plane over the northeast of Scotland in a grid pattern. So it grid pattern all over the area. And it took two beams. It took a straight down beam, so we got the picture of the top of the building, and a beam at an angle, so that we could then recreate the buildings in 3D. For spaces that we couldn't do that with, we have a drone. So we flew the drone over the area as well and collected anything in higher detail that we needed to get. We also have thermography. We're able to collect thermal data at the same time with the drone, so that we can then map that onto the buildings at a later point as well. We have terrestrial laser scanning. The scanner that I just showed you sits like a camera, spins round and collects all those points. SLAM scanner. I couldn't find a diagram for a SLAM scanner, so I used the Ghostbusters backpack, because that's pretty much what it looks like. And you wear this and you walk around, and as you're walking around, it will scan the streets and areas and spaces that you walk through. And then we also have digital photogrammetry. So going around with a camera or cameras, taking lots of pictures of the buildings, and then putting those in high definition as well. And this is a bit of a scan of Union Street, which is the main street that runs through Aberdeen. And this is what a terrestrial scan looks like when you put it all together. And you can see, kind of see the points. This is quite a high definition one. So right down here, you can see all these little points, and these are part of that 2.4 million per bit scan that I was talking about. This is about 10, 20 different points throughout this area in Aberdeen. This is the main square called Castlegate. You'll see this square again in a second. Sorry. Apologies, something caught my throat there. Okay, so why do we do it in 3D? Who knows what this is? What's that? Anybody want to shout? Do you know where it is? Everybody know where it is? It's Islamabad. But that's easier, isn't it? If I put that image up, you know straight away that's Islamabad. But when I put the image of the map up, it takes you a while to pick that up. You know it, it's your city, you know what the layout's like, but it still takes you that couple of seconds to interpret that data. If we use a 3D representation, you don't need to worry about any of that. You don't need to worry about your brain working out what you're seeing, because you know, because you walk about it every day. And that's the power of what we're trying to do. Okay, how many of you play games? Excellent, I got much more response from that. Great, right? I do too. Just me. Actually, that's quite a calm version of me. That's probably more like me playing games. But games are really important for what we're trying to do. Most projects that do this type of activity do a scan, and they put that scan into a expert program that then generates an option or a set of options for the developer, and that goes to the developer, and that's it. What we're trying to do is make an interactive platform that will continue to grow and grow and grow, like a computer game. The cool thing about it being a computer game is we automatically involve a whole set of people who don't usually get involved in decisions. Why do we use computer games? That's what they're designed for. Modern latest computer games, so this is Ghost, and then this is, the top one's not out yet, the bottom one's one of the football games, and you can see how realistic they are. They're designed to create realistic, large-scale, interactive environments. That's what a game is. So why do we not use those systems to then make digital twins? And you can see here, this is an example of Unreal's rendering engine and the type of detail you can get from that rendering engine. So what we're trying to do is collate all that information on top of a game engine to develop a system so that it doesn't matter what your background is. It doesn't matter if you're a student, if you're a professor, if you're a decision maker, if you're in the government, if you're a planner or developer, you can understand the data around that decision. And if you can understand the data, you can then be involved in it. You can give your feedback, and then we get to community decision making. And we're building all of this on top of one of these game engines. We're building this on top of the Unreal Engine. So to give you a little example of this will start a video in a second. So this is the raw point cloud of Aberdeen that I showed you earlier. All of these separate points are all the points collected by that scanner. We take all those points in, we put them into the game engine, and we turn it into this. High definition, photorealistic, interactive image of the city centre. This is one of the first versions of the model that we built. I'll show you something much cooler in a second. Thank you. This is one of the big buildings right in the centre of Aberdeen that we scanned and then created the 3D model. You can see the level of detail we're getting on the city crest. This is just a still image of, do you remember I said about Castlegate, the little square right in the centre of Aberdeen? This is the same square. And this looks like a photograph. This isn't a photograph. This is a still from the engine rendering out that display. And we can also display information on it. This is an information display of the energy performance data, the energy efficiency of the buildings. Each of those columns here with a letter, I don't know whether it's a global energy efficiency rating, but in the UK we rate energy efficiency from A to F. A is really good, F's really bad. On this image, A will be green, F will be red. Each of these letters represents a residence within that building. So if we have a building like this one way over in the corner here with a big tall tower sticking out the top of it, that's a building that might have 300 flats in it, 300 apartments in it. If it only has 1 or 2 lights, it might be 2 apartments or a single dwelling. And what this lets you do really quickly, you can spot all these green ones in the back, some yellow ones down here. So very quickly, a decision maker can look at that data that has been stored in different types of databases for years, but never looked at in this way. And they can say, we need to invest in that space there, because that's where we can have the most impact. This one is showing whether the building is meeting its potential. So whether that residence is meeting its potential energy performance. And this really lets you highlight most of these buildings are not meeting their energy performance. Anybody looking at that, once you've explained that that's the data, can see that that's they can understand and get involved in that decision. Okay, I said I would show you an even cooler video. So I'll talk through some of what's on this, but this will be a kind of demonstration of the whole system. It's about 2 minutes long, but as I say, I'll explain what's going on throughout it. I'm just going to take a wee sip of water before I start. This is actually our university campus. This is our GU. And this isn't a flyover. This isn't something that we've rendered out. This is somebody live flying the system, looking at the city. You can see the level of detail along the coast. Aberdeen, as I said, is in a beautiful space. And this is our city. Because it's in a game engine, we have full control over things like the weather. We can make it rain. Sometimes rains in Aberdeen. We can make it snow. But we can also make it a lovely summer's day. We can change the time of day. And this is the example that I was showing you with the energy performance data. So you can highlight whether it meets its target. And we can display other types of data. This is displaying what investment there has been in particular areas previously and whether the investment has increased. This is an example of, again, that city square right in the middle, where we have put together all those different types of scans, the terrestrial scan, the LiDAR, the drone scanning, into one environment. And you can see the level of detail that we're getting. We've even animated some little birds in it to make it look more realistic. So this isn't a video, this is real rendering from the system. This is a little cross that sits right in the middle. It's a market cross, we call it, that sits in the middle of Aberdeen. We can also do some realistic flood modelling. So here we're trying to flood our university campus, but we're holding back at the last minute. But what this demonstrates is we can do that type of flood modelling in it. We can also overlay potentials for different buildings. This is a potential for a building on the campus. And as I said, we can overlay thermal information on that as well. And really detailed scans of the entire city. If any of you come to Aberdeen, this is probably how you'll arrive there. And then just to show, again, the level of detail and the expansion that we have. So we have the majority of the city, but our point is that actually we're going to do this for the whole northeast of Scotland. It's quite a large area, and be able to show those types of models and those types of decisions, supporting those types of decisions in those environments. Not again. There we go. I was really interested in some of the other talks I've heard throughout the conference about applications of AI, about applications of machine learning, and that's exactly the type of thing that we're using this system for. At the minute, we're displaying data, but our hope is that this quickly moves to, perhaps for a planning decision, we use a generative AI to develop possible options. We can then simulate those options. We could simulate thousands of options, hundreds of thousands of options that an AI can develop that wouldn't happen through a normal planning process. We can display information from Internet of Things sensors right on the digital space. So loads and loads of opportunities for both how people interact with data, how AIs can be used to explain some of this complex information, and also how we can get people involved in these types of decisions. So just to conclude, games technology gives us that ability to investigate, simulate and design like we never have before. It's given us this ability to play with options, to use games to determine if these options will work, and to be able to demonstrate them to people who maybe haven't seen them before. Luckily for us, those of you at the front didn't see, but nearly everybody put their hand up when I said who had played games. The next generation is already way ahead of us in this. So by getting everybody involved in this type of process, it pushes that whole development and system on. So the last thing I was going to do was leave you with a quote. So we don't stop playing because we grow old. We grow old because we stop playing. So for me, I'm still a gamer, although I'm probably getting quite old now. But keep playing games, because those types of games, those types of things that we do on these types of systems will be what drives some of this forward, and will be what involves people in decisions, in AI, in these types of processes that have never been involved in them before. And if we can get the younger generation hooked into this through the gaming technology, then hopefully they'll sort out some of the problems that we've caused. So thank you very much. And just a shout out to the rest of the team, but it's been an absolute pleasure speaking to you. Thank you.